How does a helicopter fly? Do you know this? Let's learn more about the helicopter flying system. The first controlled and sustained flight of an airplane was conducted in December of 1903 by the Wright brothers. Years passed and aeroplanes became increasingly sophisticated and powerful, but their design and functionality had several limitations. They needed a long runway to take off and land, and they weren't all that effective for certain purposes. These problems were solved, however, when another powerful flying machine was invented, the helicopter. A helicopter, or chopper, is a type of aircraft that uses rotating wings called rotor blades to fly. They are a critical component of any helicopter's flight. Helicopters have several advantages over fixed-wing aircraft. First of all, they don't need long runways to operate. They can take off and land pretty much anywhere. It doesn't matter if you're in the middle of a forest or the backyard of a house, choppers can't access small places. This comes in very handy during military operations or even civilian and medical emergencies. Choppers can also pause mid-flight to load and unload cargo, which is why they're so widely used during rescue operations around the world. Although helicopters aren't as fast as aeroplanes, they are much more maneuverable and offer a great deal of flexibility in terms of the places you can go. But what makes a helicopter fly? Once a helicopter is off the ground, four aerodynamic forces act on it: weight, thrust, drag, and lift. Weight is the combined load of the helicopter, which includes the weight of the helicopter itself, its crew, and the cargo. This force pulls the helicopter downward as a result of gravity. Thrust is the force produced by the rotation of the helicopter's blades. Its direction can be forward, rearward, sideward, or vertical. Drag is the force that opposes the movement of the helicopter through the air. Finally, lift is the upward force acting on a helicopter that pushes it up and keeps it in the air. For any object to fly in the air, it must have the force of lift pushing it upwards, but for that to happen, the air must pass around an airfoil. An airfoil is any surface that produces more lift than drag when passing through the air at a given angle. So, what's the airfoil in a helicopter? It has spinning blades. The blades of a chopper are uniquely designed so that they can generate lift. More specifically, they are curved on top and flatter at the bottom. This curved shape makes air flow faster over the top, which causes the air pressure on top of the blades to decrease. This happens due to Bernoulli's principle, which states that an increase in the speed of a fluid occurs simultaneously with a decrease in the pressure exerted by the fluid. In simple words, what this means for helicopters is that when air flows at a faster rate above the blades than below them, air pressure on top of the blades decreases. This air pressure difference between the top and bottom layers of the rotor blades generates lift, which gets the helicopter off the ground and keeps it in the air. The physics of flying an aeroplane is precisely the same as that of a helicopter. An aeroplane flies by moving very fast so that enough air passes over its wings to provide lift, whereas a helicopter flies by rotating its blades very fast through the air to generate lift. However, no helicopter can fly with just one set of rotating blades. This is because of Newton's third law of motion. For every action, there is an equal and opposite reaction. Apply this law to helicopters, and you would realize that the rotating blades would cause the body of the helicopter to rotate, albeit somewhat slowly, in the opposite direction. This kind of twisting force that causes rotation, also known as torque, would make the helicopter totally uncontrollable and would have disastrous consequences. Therefore, this torque generated by the main rotor blades must be compensated for somehow, which is where the tail rotor comes into play. You may have seen a second, smaller rotor mounted on or near the tail of a helicopter. This is called a tail rotor, a sideways pointed propeller powered by the engine of the chopper. This rotor counteracts the torque generated by the main rotor, thereby ensuring that the aircraft remains stable during flight. In some choppers, the tail rotor is built directly into the tail. This design is called a fenestron, or fantail. There are other designs of helicopters that don't have a physical tail rotor at all but instead use a different method to counteract the torque produced by the main rotor. For example, a second rotor can be mounted below the main rotor. The blades of this rotor spin in the opposite direction to compensate for the torque created by the main rotor. Some choppers also have rotors mounted on either end of the craft that serve the same purpose. Helicopters steer in a given direction by generating more lift on one side than the other. Basically, when they need to go left, they generate more lift on the right, and vice versa. Some choppers can even fly upside down. An inverted chopper can use its blades to generate lift towards the bottom of the chopper the same way it normally uses them to generate lift upwards. You may have seen stunt sequences in movies where helicopters fly belly up. Needless to say, this is a very complicated and potentially dangerous maneuver to pull off. There are a ton of mechanical limitations to flying a helicopter upside down, considering that regular helicopters are not designed to fly belly up. Such a risky flying maneuver is usually executed by highly trained pilots in specially designed helicopters. Helicopters do not fly as high as aeroplanes do. It's common for commercial aeroplanes to fly at altitudes of 35,000 to 40,000 feet. For helicopters, that range is much lower, as they usually don't fly above 10,000 feet. The higher you go in the air, the lower the air density becomes. This negatively impacts the amount of lift the blades can generate, as the air becomes too thin for the functional requirements of a helicopter. This is one of the reasons why it's considered so dangerous to fly helicopters in high-altitude regions. However, specially designed helicopters can fly much higher than regular helicopters and can be used strategically for special purposes. However, what if a helicopter's engines fail mid-flight? What happens then? In the absence of engine power, rotors don't have enough energy to overcome aerodynamic drag on their own, so the chopper will begin to lose altitude. Since it's the air flowing over the blades that allows a chopper to fly, a safe landing is still possible in the event of an engine malfunction. Without the power of the engine, you would need to maintain a minimum RPM. In other words, you would have to ensure that the rotor blades maintain a minimum rotating speed. To that end, pilots are trained to use airflow to their advantage. The phase of flight when the main rotor blades of a helicopter spin by the action of air moving up through them, rather than the engine's power, is called autorotation. Pilots often use autorotation to safely land choppers in the event of engine loss or some other type of critical damage to the aircraft. The United States Army actually presents the highly regarded Broken Wing Award to aircrew who minimize or prevent loss of life through outstanding airmanship during emergencies. Helicopters can be used for a variety of purposes, including acting as aerial ambulances to transport patients and military combatants. They can be loaded with water that can be used to extinguish raging forest fires. Radio stations and televisions fly helicopters over metropolitan areas to report on live traffic conditions. Military forces use them to transport troops and attack targets. Needless to say, helicopters are an invaluable part of the aviation world. In the end, a helicopter's power comes down to its rotor blades and their ability to continue generating enough lift. That's probably why there's a very fitting expression in the world of aviation: helicopters don't fly, they beat the air into submission.